Okay, this is a continuation from the first video. And be kind, because these videos are really hard to do. If I make any mistakes, I have to start all over from the beginning, and I'm just not going to do that anymore. Okay, so let's do the best we can. I'm going to continue where I left off, and we talked earlier about what an event A represents and what event B represents. And now we're going to talk about what's the probability of A, that would be that it's a female, plus the probability of not A. Well, if I look at that, the probability of it being female is 0.580. We did that before. The probability of it not A, that would be a male, it's 0.420. The sum is 1. If you look at the probability of B plus the probability of not B, it's always going to be 1. Why? That makes sense. It makes logical sense. It's either one or the other. If you add the two probabilities up, it's always going to sum to 1. That's 100% of what could possibly happen. But they just wanted to point that out to you. Another type of probability, this is the one we're going to go with, is called a conditional probability. Pulling apart the two-way table helps to define a conditional probability. So what they're going to say is, suppose that a randomly selected student is female. So I'm just going to look at that top row there. What is the probability that the selected student participates in an after-school athletic program? This probability is an example of what is called a conditional probability. So I select a female, and also what is it that they're going to participate or not participate. Okay, so what we're dividing by is going to be different. So if you look at this, the following examples of conditional probabilities. The probability that if a randomly selected student is female, okay, so I picked my female out of the bag, and then that she participates in after-school programs. So we're looking at right here, 232 is in my table. However, I'm not dividing it by the total number of students this time. Let me get my pen going here. I'm dividing it by the total number of females because I selected that female first. Okay, and that's kind of the difference on that one. So if you want to know what's the probability of random selected students female, so I'm going to say out of all the females, she does not participate. It's going to be over 348. So the difference here is that you're dividing it by the total, that she's a female. Let's go see if I get that. There we go. So it's called conditional probability. And the big difference is you're going to divide by the condition, not by the total number of students. Okay, so describe two conditional probabilities that can be determined from the following row in table 1. So now they're looking at males. So you could say if a male was selected, the probability that he participates in would be what? 168 out of 420 that the male participated. Okay, if out of all the males that participated, this would be the probability of them not participating. Okay. And they just wanted the words. Said describe. I did the actual probability. Describe two conditional probabilities that can be determined from the following columns. So the conditional probabilities, let's see. Well, you're randomly selecting any student that, this time you're randomly selecting students that participated in the athletic program. And then you get to determine whether they're male or whether they're female. Do you see the difference there? So if a randomly selected student participates in after school, now is the student female or is the student male? Does that make sense? Do you see now you're looking this way? So the first thing you're looking at is if they participate. Then you go to the student is female or the student is male. Okay, determine the following probabilities. A randomly selected student is female. What is the probability that she participates in after-school athletics? Explain how you determine your answer. Okay, so I wish we had the table up there at the same time. 232 females participate, and I'm looking at all the females, so it's 40%. Okay, since it's known the selected student is female, I'm going to look at the row for female students and use that information. Okay, and you should have your notes out and you should be able to see the table. A randomly selected student is male, so it's not going to be divided by 1,000. It's all of the male students. What's the probability he participates in after-school athletic programs? So you're going to look at all the males. There's 420 of them. And you're going to say 168 participate. It's 40%. Oh, how interesting. It's exactly the same. A student is selected at random. Now you're looking at all the students. What's the probability this student participates in after-school athletic programs? Remember, this is 1,000 students, and we know that 400 participate, so it's 40%. Very interesting. Based on the answers, do you think that female students are more likely to be involved in after-school athletics programs? It says 40% participate. 40% of the guys do. I'm going to say no. It's exactly the same. It indicates that male and female students are equally likely to be involved in after-school athletic programs. Okay, now I want to talk about that concern the female student expressed in the beginning. Okay, it is interesting that at this school, the probability that a randomly selected student is female is 58%. There are more female students than male students at this school. As a result, the facilities are assigned equally, given that both female and male students were found to be equally likely to be involved. The number of female students involved in after-school athletics program is greater than the number of male students and might explain the concern regarding the facilities. Do you see the difference? Can you see how, it's exactly the same, but you're basing it on the probability that the females participate, the probability that the males participate. However, if you just look about the students, remember the total number of students participating, it's exactly the same. So you kind of have to think about this and be able to interpret it correctly. Okay, lesson summary. Your data organized in a two-way frequency table can be used to calculate probabilities. That makes it really easy. They can also be used to calculate those conditional probabilities. In certain problems, probabilities that are known can be used to create a hypothetical 1,000 two-way table. The hypothetical population of 1,000 can be used to calculate conditional probabilities. Probabilities are always interpreted by the context of the data. Okay, good luck, you guys.